So, stem and leaf, frequency, and histogram, and dot plots. The first one we're talking about is a stem and leaf plot. Now, basically, what we're talking about here is if you had a tree and you had a stem, and you would have leaves on them. I'm not an artist, so we have these horrible looking leaves that look like banana peppers. I don't care. Okay, but the stem is usually going to be your tens digit, and these are going to be your ones. Okay, so hopefully it'll make sense once we start doing it. So if you look at this data, okay, we have 42, 40, 40, and so forth. The lowest tens we have is our 30s, and the biggest one we have is 7, 70. So we're going to put 30, 40, 50, 60, 70. The tens digit. That's going to be our stem. Now, we're going to go through and look for the smallest ones in order, the 30s. So obviously we want to look for a 30. So we go through, and we don't have any 30s. We look for 31. We don't have any 31. So we do find a 32. So we're going to put a 2 here. We're going to go in order with the leads. We're going to find another 32 right here. And it's a really good idea to mark these off as you go. Now we're looking for a 33, which there is none. 34, there is none. We have a 35 here. We have another 35 here. And then we have a 36. There are no more 30s. Oh, no, wait. Sorry about that. There's a third 35 right here, which is why we double check. And the reason we cross them off is that if we end up with some left over, we just go ahead and erase and add them in. And then we have that 36. Now 40s. Looks like we have 1, 2, 3, 4 zeros. Now you want to kind of keep them lined up. So 1, 2, 3, 4. You want to line them up, and you'll see why in a minute. Now there are no 41s. There's a 42 right here. There's a 43 right here. It does not look like there's any 44s. There are 2 5s though. We'll keep going kind of in an orderly fashion. There are no 46s, 47s, there is a 48, and there's no 49. Now 50, there's 2 50s. 60s, there's a 61. 50s. See, this is what I'm talking about. Look, I did 61 right, I did 70, boom, okay. I missed a number. It happens. It's very easy to do. But that's why if you didn't cross them out, there'd really be no way to go, oh, I missed something. So you really do want to just, I'm not talking about blot them out, completely obliterate them. Just a line, a simple line. There's our stem and leaf plot. Now, the reason I said write them kind of in columns, okay, you don't draw columns here, but you want to see why. It's very easy to see, which tens had the most. Well, in the 40s. Numbers in the 40s, there were more of those than anything else. So more animals that could run in the 40s than anything else. Okay, now the weight of packages. Okay, now remember I said the 10s generally and the 1s. Well, there's really not, for numbers 1 through 10, there's really not. So for the single digit, there's not really a tens, but you put a 0. Okay? And then we're going to look and see how high does it go. Looks like 41 is the highest, there are no 50s. So we're going to do 0, 1, 2, 3, 4. Now, we go through and find the smallest number. There are no 1s, so we're going to look for 2s. 1, 2, 3. I don't think there are any more of those. So I put, there's 3 of them. Right there, 1, 2, 3. Now I'm going to look for 3s. It looks like I got 1, 2, 3 of those. So I'm going to just orderly 1, 2, 3. 4s. Looks like I only got 1. 5s, 2. 6s, 7s, 8s, oh, 2 9s. And that looks like it for 0 through 9. Now I'm going to look for my 10s. Now, one thing I do want to talk about with the 10s, let's say we were doing temperatures, okay, in Texas in the summer. Well, you'd obviously be going into the hundreds. So you probably, your stems would be like 8, 9, and then you'd put 10, 11, 12. The leaves will always be 1 digit. Okay? You might have more for the stems though. Okay, so we get done with the zeros, the 0 to 9. So now we're doing the teens. So we have 110, it looks like. It looks like we have 111. Looks like we have 112. No 13s or 14s. We got 2 15s, so we put them neatly under there. And then there's no, let's see, there's 116 right there. 6. 117 right there. And we have an 18 right there. Now for 20, we got 20, 22, and 23. For 30s, we got 35 and 38. And for 40s, we have 41. Now, in this case, we had, again, something for everything. But let's say there were no 30s. Okay? You'd leave the 3 on the stem just for organization, but you would not put any numbers for the leaves. You definitely would not put 0, like, oh, 0 numbers. No, because that would be the number 30. So you just leave it blank. There's a stem leaf plot for that. And that's it. That's all you do. It's very simple. Okay, a frequency table. So you're going to construct a frequency table based on these scores. All right? So we're going to use equal intervals. So basically between 4 and 5, 5 and 6, 6 and 7, and so forth. So once you hit 5, you're in the second one. So 4s. Anything with a 4 in front of it. 1, 2. That's it. There's little tallies there. And then the 5. 1, 2. Oh, these are in order, so it's not too tough there. 1, 2. 6s, 1, 2, 3. You go 1, 2, 3. 7s, there's 1, 2, 3, 4. 5. 1, 2, 3, 4. Then we put the left dash through there for 5. 8s. 1, 2, 3. 9s. 1, 2, 3. 10s. 1. And then you just count them up. So there's 2 of these, 2 of these, 3 of these, 5 of these, 3 of these, 3 of these, 1 of those. That's it. Then we. All right, a histogram. Now this histogram looks like a what?
A bar graph.
Bar graph, yeah, because it has bars. But let's think about the difference. Let's think about the difference between this and a regular traditional bar graph. With a regular bar graph, we actually have like numbers here, like 1, 2, 3, or we might have colors like red, yellow, green. And then you pick your favorite ones, and have the number here, 1, 2, 3, 4, 5, and you have bars like this. Okay? So you still have bars. The difference is, on a histogram, we don't have this column representing one thing. That column is representing a range of numbers. So this is how many between 4 and 5. How many between 5 and 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. It's a range of data. You're putting them all in one column. So in other words, we could have made a histogram very easily with a bar from 4 to 5, that's too high, 5 to 6, 6 to 7, 3 high, 7 to 8, 5, and so forth. So they'd be based on ranges instead of just an individual column. So that's the biggest difference. The other big difference is these are always numbers. Okay? You cannot have words down there. because you can't say, hey, what's your favorite color? Make a histogram and go from red to yellow, yellow to green. You can't have a range of colors. It's either red or green or whatever. But you can't say, well, like animals. What's your favorite animal? Oh, somewhere between horse and dog. You can't do that. You can't have a range of animals. It's just one animal or another. Okay, so this is the data that we got. So these are the number of points, 4 to 5, 5 to 6, and this is how many people got that many. So 2 people scored between 4 and 5, 5 people scored between 7 and 8, and so forth. Okay, that's how you read it. Now we're going to make our own. So between 85 and 90, there was 1. All right. Now the problem with this one is when you're doing something like this, it's kind of hard to, this goes up to 5. So you're just going to make a little tiny one like that, 85 to 90. Then 90 to 95 is 5. So it's going to continue from here, go up there and down. 95 to 100 is 28. So 28, you're going to go all the way up here, almost to 30, and come down. Not quite 30. 19, you're going to go right here under 20 and down. And then 7, you're going to go just a little, almost halfway, like so. That's it. That's all you're doing. That's how you make a histogram. You just take the data, count up the number, the frequency, how many there are for each range, and then draw your bars like that. All right. Next, use the histogram to answer the following questions. How many people are there in the interval between 130 and 135? That's this one right here. Okay? Since it's going by 2s, there's not much guesswork here. That's going to be 1. Now, let me point this out. If this was going up by 5s, and you saw the line right here, you might guess 2 or 3. It's up to you. There's some freedom there when you're estimating on that big of a range. But with it only being 2, that's obviously going to be 1. Now 110 to 115, where's that? Well, that's this one right here. That would be 7. 120 to 125, that's right here, and that's going to be 2. Dot plot. Survey of how long does it take for you to eat breakfast have these results. Okay? So 0 minutes. I guess that's 2 who don't eat breakfast. 3 people. So all you do for a dot plot is you're going to put a dot, 1, 2, 3. You kind of space them out evenly. 1 minute, 0 people. 2 minutes, 1 person. You keep it level with that one. 3, sorry, my bad, that was supposed to be over at 2. 3 minutes, 1 person. 4 minutes, 2 people, so you put a dot here, you put a dot here, kind of even with that one right there. 5 has 3, and 6 has 3. That's a dot plot. That's it. It's kind of like a bar graph. Literally, if you had made a bar graph, you have a bar at 0, a bar here, a bar here, a bar at 2, bar at 3, bar at 3. So it's basically the same thing as a bar graph. It's just you got columns of dots instead of bars. That's it. That's all you're doing differently. Okay, so the following data represents the age of cars in years. Make a dot plot of the data. So, in this one, you're going to look and see, it's already in order, so it's kind of easy. So, there's only 1 0, so you put 1 there. There's only 1 1, you put 1 there. There's 2 2, so you're going to put 1 here and one above. There's only one 3, so you put one right there. There's only one 4, you put one right there. There's 2 5s. When you do this, you kind of make sure it's kind of even with the 2, so we don't have bars going across. For 6, we have 1, 2, 3. So 1, 2, and 3. Kind of space them out evenly. Now 7. Whoa, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And yes, it's going to be higher. You make it closer, it'll be, obviously, whatever. That's all you do. You just make a dot, as many dots as there are numbers. Same thing. Now here, though, notice you don't have anything. You just have a line. The numbers are obviously going by tens, so you just put, space them out, 40, 50, 60, 70, 80, 90, 100. And then you just count. 1, 2, 3, 1, 2, 3. 1, 2, 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 70, only 1. 60. There's another one out of place, so just put it up there. 80, 1, 2, 3. 1, 2, 3. And you just kind of keep this, try to keep it as even as you can. 90, there's 2. 100, there's 1. That's it. That's your dot plot. Now, some people instead of dots, and this is okay, choose to use X's. Doesn't matter. If you want to do X's, it's up to you. You don't have to. Your choice, your freedom, your graph. Either one of those would be acceptable, X's or dots. You want to leave it half and half on here just to remind yourself, that's fine. Okay, we're comparing 3 representations of the same data. So we have a histogram, we have a stem and leaf plot. Okay? Well, that's 2. I don't know where the third one is. The distribution is a lot clearer in the histogram. Okay? You can see what's happening a little bit better in the histogram. The box plot provides exact values for the minimum and maximum. Okay? You don't know exactly where. Now, in this one, it happens to be that, this one, it looks like, 4.1. This one looks like 10. But this one tells you where the actual minimum is. This one, it could be 4.0, 4.1, 4.2. You just know the data. That's how many there are between 4 and 5. All right? But the box and whisker plot gives you a little bit more detail. So they're both different ways of looking at data. And that's it.